Oh yeah, I forgot to ask you about that. All right.
My notebook's at the top of the mountain.
What was that?
I left my math notebook at the top of the mountain. What the hell?
Why would you take it to the top of the
Because he was studying at all times.
He was studying watching the math notes.
Yeah, wait.
That just registered in Austin.
Why? You guys went up there to do homework? And you decided it would be a good idea to bring your school backpack? That's what you messed up, dude. The average hiker starting to do that backpack.
It's okay, it was the one.
Oh, okay.
He's recording this tour is sitting right there.
Something to get your notes down.
Can I just take pictures of the old ones?
Yes, but for now you're writing this down in a new notebook, piece of paper, or somewhere.
I'm using another notebook.
Okay. All right. So review from, this is review from last year because you did do these last year. Actually, I don't know if you did hyperbolas.
No.
Yes, no, maybe so. All right, there's different kinds of hyperbolas. This is the first one, x minus h quantity squared over a squared minus, and then y minus k quantity squared over b squared equals 1. This looks a lot like the standard form for an ellipse. I'm going to show you the standard form. This is it right here. Can anybody see what the difference is between the ellipse standard form and the hyperbola?
This is a minus.
That minus sign, that's the big thing right there. All right, so an ellipse has a plus sign and a hyperbola has a minus sign. It does make a difference. All right, this is what the graph is going to look like. For now, just draw this dotted X. I'll explain what it is as we go. I'm going to put a dot on the right, a dot on the left, and I'm going to open these kind of like parabola shapes going right and left. All right, hyperbolas are kind of like parabola shapes, but there's two of them. There's either going right and left or going up and down. These dotted lines are the asymptotes. That determines how wide or thin your hyperbola is going to be, are the asymptotes. And we'll figure out how to draw those asymptotes. What you'll need to know, first off, this is the center. These are the vertices. And what do we know about the center and the vertices? It's equidistance. All right, and then this is going to be the foci. Zach, will you close the door, please? Thank you. All right, what was the question? Yes. Yeah, so from the center to the right vertex and the center to the left vertex, it'll always be equidistance. Thank you. As well as the center to each foci would be equal distance as well. Do you guys agree with that? That's review from the ellipse and the hyperbola. I'm sorry, parabola. All right. An ellipse has a plus sign. What do we know about addition? Is addition commutative?
Yeah.
5 plus 3 is 3 plus 5 all day long. Do you agree? Is subtraction commutative? Is 5 plus 3 the same as 3? I'm sorry, 5 minus 3 the same as 3 minus 5? No. So does the order in which these appear make a difference? Yes.
Yeah.
So if I wrote down here y minus k quantity squared over b squared minus, and then x minus h quantity squared over a squared, and it still equals 1. How does that change our hyperbola? Any thoughts?
Means the b would be bigger.
The what? The what?
Or never mind.
Never mind.
Could it go up and down?
Up and down instead of right and left is correct. All right, so we still have our asymptotes. And again, we'll figure out how to get our asymptotes and how to get our shapes and foci and vertices and everything else. Put one up, one down. And remember, the asymptotes determine how wide or thin your hyperbola is going to be, your U shape. And then your foci are always inside the cups. All right, so when you're when you're looking at shapes, remember we've talked about how to determine which ones are which. What is the first shape you should always try to look for to determine if it is a parabola? Why parabolas? Because they're the easiest to figure out because it's the only one that has one squared, either x squared or y squared. So the first thing you're looking for when it says name this shape, you look to see if it has one squared. If there's one squared, it's obviously going to be a parabola. If there's two squares, what are our choices? A circle, an ellipse, or a hyperbola? How can you tell whether it's a circle? Do you guys remember? There's two squared, an x squared and a y squared. The leading coefficients are the same, and they're both positive or both negative, right? And if they're both negative, could we divide the negative and make them both positive? All right, an ellipse also has two squares, also both positive or both negative, but what do we notice about the leading coefficients? They're different, 5 and 1, 7, or different leading coefficients, yes? Hyperbolas, typically hyperbolas are the second ones I look for. They're the second easiest to find because it's the only one with two squares and a what sign? A minus. One of them is negative, either the x squared or the y squared. All right, we'll talk more about that as we go. Questions so far? All right, center. Center is, as always, HK. What you want to be careful with is on this one right here. Kids are so used to doing HK for a second, they get to this one and they flip them and they say KH. It's still HK, but the H is over here with the X, not with the Y. Do you see that? Yeah, so the order flips on this one, so be careful. All right, focal length. What do we need our focal length for? To find what? The foci. Yes? All right, c squared equals a squared plus b squared. Where have we seen a formula similar to this? Pythagorean's theorem. C squared equals a squared plus b squared. Do you agree? All right, so where else have we seen one? Very similar, not exactly, but similar to this one, just in this unit. Let's go back to the ellipse 11.4 in your notes. Focal length formula. How is it different? This one's a squared minus b squared, where the one we just wrote down is a squared plus b squared. I put absolute value here, but I didn't write it here. Why not? It's always going to be positive. Why is that? Because if I'm adding two positives, it's going to stay positive, right? Where this one, if I'm subtracting, there is a chance it might be negative. As we went through this lesson, eventually I dropped the absolute value and we just did what? We always made sure which number came first. The bigger. We just did big minus small. So if you can remember that, you don't need the absolute values eventually. Got it? Okay. Because if you do the big minus small, would you need the absolute values? No. All right. Questions on focal length? All right. Do you remember major axis and minor axis? We talked about that before. We don't talk about major axis and minor axis on this one. We talk about transverse and conjugate. I know. All right, so let's write this down. Length of the transverse axis. Now, the reason we don't use the word major and minor is because with an ellipse, what did I say about an ellipse? Do you remember what I said? Something about the center and the foci are always on the axis. Do you guys remember that? Yes, I said vertices are always on the major axis, foci are always on the major axis, and that's always true for an ellipse. That is not true for a hyperbola. So we don't use the word major axis anymore because sometimes it is on the minor axis. What determines where the vertices and the foci, what direction they are, right and left or up and down? What determines that?
If the B is in front.
What comes first?
Mm-hmm.
Yes. If X comes first, your vertices and your foci are going to be running right and left.
Yeah.
If your Y squared comes first, your vertices and your foci are going to be running up and down. Anything to do with the major axis?
Yeah.
No. Kids get so stuck on the major axis with an ellipse, they try to apply that rule here and it messes them up. Please do not do that. Their major axis out the window for these problems. We're looking at what letter comes first. All right. Length of the transverse axis is the distance between the vertices. Now, is the transverse axis always going to be the longest? Nope, it's not always going to be the shortest, but it's always going to be the distance between the vertices. All right. Length of the conjugate axis is the distance between the points that are not the vertices. Okay, so right now it may not make too much sense because I don't even have points on there that are not the vertices, but when we get to graphing, I'll explain a little more what these mean. For now, get them down, so when you look back at your notes and you read it, it makes sense. When you go back, it'll make more sense because we would have done examples with them. All right, last piece before we actually start graphing is the equation of the asymptotes. Equation of the asymptotes. Now, did we draw asymptotes up here when I graphed these up here with you? Yeah, I told you what were the asymptotes here. Those, that X, the dotted lines? Yeah, so there are two of them. What kind of function are these? Are these parabolas, absolute values, linear? Linear, do you guys agree they're both linear? This one here has what kind of slope, positive or negative? What about this one here? Okay, now this changes direction. Does it still have a positive slope asymptote and a negative slope asymptote? Yes. All right. Okay, so what do we need for the equation of a line? What's the formula for the equation of a linear graph? Okay, y equals mx plus b. Do you guys all agree? Oh, thank you. Y equals mx plus b. Is there another one? The point slope form, what does that one look like? Do you guys remember?
Is that the h2 minus h1?
Yeah, it's the y minus y1 equals m parentheses x minus x1. This is the one I will be using throughout this lesson, throughout this unit. Does that mean you can't use y equals mx plus b? No, you're allowed to if you want to, but this one is going to be easier. So why make things harder? You don't have to. Stick with the easier form. Because this form, you just plug in your slope, you plug in your point, you're done. You don't have to worry about finding b. All right, so let's review really quick what stands for what. What is m? M is the slope, rise over run. And what is x1 and y1? It is a point. Now, can you take a look at the two asymptotes in this graph right here? Do they have one point in common? Yep, this point right here. What about these two lines? Do these two asymptotes have one point in common? Okay, I recognize that it's the origin. What else could I say about this beside it being the origin? This point is also the what in relationship to the graph. The center. Do you guys agree with that? So is that going to be pretty easy to find this point? Knowing that it's the center of your hyperbola. Yes. All right, so if you want to put a little note here, center. So again, when you go back, it makes sense. Oh yeah, I remember that. Center of the hyperbola. We're ready? Okay. We are going to find a lot. So let me just write it down with you. Find the center, vertices, foci, length of the transverse and conjugate axis, equation of the asymptotes, and sketch. I know. I know. All right. Parentheses. Y minus 3 quantity squared over 4 minus parentheses x plus 1 quantity squared over 36 equals 1. All right, how do we know that this is a hyperbola and not an ellipse or a circle? Minus sign. Do you see that? Right off a minus sign, it's a hyperbola. Okay, before we even start to sketch, what letter comes first?
B.
Okay, the B comes first, the Y comes first. Do you agree?
Yeah.
Because the Y is coming first, is it opening up, down, or right and left?
Up and down.
Up and down. Okay, so make that note to yourself right now. It's opening up and down so that you don't forget that when it comes to sketching. Up and down. All right, first thing I'm going to find is the center, and I will tell you this. Actually, I'm going to let you find it on your own. Go ahead and find the center. All right, did anybody do this? Did anybody do it? And it's okay if you did. No, no one's going to say anything. This is the biggest, most common mistake made on this particular problem on the test. Why is this wrong?
Because A needs to be
Flip. Y is first, and that 3 goes in the Y spot, and where X is, that -1 goes in the X spot. Do you agree? So what I should have here is what? -1, 3. Do not make that mistake on the test. There will be a handful of you that do. Not just because you're not listening to me today, just because you get there and you get so caught up and you forget these little things I've said to you. So practice this, make sure you know it, put a little note to yourself, look over this before the test, so you remember not to reverse those, flip those around on test day. Because when you flip the center around, what happens to everything else? It's wrong, including your graph. So be careful. All right, vertices, foci, and everything else I'm going to find after I sketch. All right, I am going to make my graph nice and big. All right. First thing we're going to graph or plot is the point, the center, -1, 3. All right. This first piece is very similar to the ellipse as far as going right and left and up and down. Now, what tells us how far to go right and left? The A or the B? Or the X or the Y? Which one tells you right and left? The number under the X or the number underneath the Y? The X, because right and left is the X-axis, yes? So how far am I going to move right and left? 6. So I would say that A is 6 in this problem. Do you agree? Yep. So right and left, 6. All right. Up and down is the y-axis, so how far up and down? 2, because I use whatever's underneath the y. So I would say B is 2. So up 2 and down 2. Now this is where it changes. If this were an ellipse, I would make this, hey Arnold head, yes? But since it's not an ellipse, it's a hyperbola, I make a box shape or rectangular shape. So, and I make this dotted not because it's an asymptote, but just because it's not part of the graph. This is just a guide to help us figure out where our asymptotes are. And then the asymptotes help us figure out where or how wide or thin the hyperbola is going to be. All right, everybody have their rectangle? Again, box shape because it's not part of our graph. It's just going to help us figure out the asymptotes. Are you ready? Okay, the asymptotes are your diagonals to this rectangle. So they will go through the center and through those corners. And these are the dotted asymptotes. So the best you can through the corners and through the center. What was that? I just made dotted lines going from corner to corner, going through the center. So from the center out to each corner. All right. Here is another, okay, well first off, which direction does it open? Up and down. We set that earlier. So if it's opening up and down and it's going towards the asymptotes, is it going to be pretty narrow or pretty wide? If they, let's just pretend they were opening right and left, would that be more narrow or more wide, or would it be wider? It would be more narrow. Do you see that? If it was sideways, they would be narrow, and opening up or down would be wide. And since this one's up and down, it's going to be a pretty wide U shape, going towards your asymptotes. Okay, so what does the rectangle help us draw? It helps us draw our asymptotes. And what do the asymptotes help us determine? How wide our hyperbola is going to be. I know that looks pretty wonky, but hopefully yours looks better. All right, vertices. Here's a big mistake kids make. They will graph it properly, but they'll put the vertices here because they say, oh, it's the 2 points furthest apart. Is that true for a hyperbola? No. For an ellipse, your vertices are the 2 points that are furthest apart, but not for a hyperbola. Wherever your U shape opened up or down, those are your vertices. So these 2 points right here are the vertices. Do you see that? Okay, so what determines which direction your vertices are going? What letter comes first? And since Y is coming first, which direction are the vertices going? Up and down. Which direction are the foci going to be going? Up and down. They're going to be inside the cups. All right. All right. Find those 2 points right there for your vertices. What are they? -1, 1, and -1, 5. Do we all agree with that? All right, one thing we want to make note of, what number is staying the same or staying constant? The x, the -1, and which one is changing? And does it make sense that if you're moving up and down that x is staying the same and y is changing? Okay, now because we're able to graph these points, because they're whole numbers, it's easy for us to just look at the graph and figure out it's -1, 1 and -1, 5, yes? But we can still do that thing that we talked about last week with the plus and minus. How far up and down did I move?
2.
I moved up and down 2, yes? So when I move up and down, which point is changing for my center, the x or the y? The y. So if I did 3 plus 2 and 3 minus 2, would I get these two numbers here?
Yeah.
What's 3 plus 2? And 3 minus 2? Now, do you have to do that in order to figure out these points? No, but does it make sense? I need it to make sense because we're going to use this concept to find the foci. Are you ready? All right, in order to find the foci, which direction am I going to move to find the foci? Up and down. So what is going to change, the x or the y? The y. So the x is going to stay -1, and the y is going to change to 3 plus or minus. And what goes in that blank all the time? The focal length. Focal length. Good question. Can anybody answer that? Where did I get that 3 from? This 3 right there. The center. Does everything come from the center? Yeah. You move up and down or right and left from the center every single time for an ellipse and for a hyperbola. Got it? A parabola doesn't have a center. It has only a vertex. All right, so for an ellipse and a hyperbola, everything is coming from the center. So from the center, I'm moving up and down for the vertices, and from the center, I'm moving up and down for the foci. Now, focal length is what we have to find first in order to know what that plus and minus is going to be. Do you agree? What's the focal length formula? C squared equals A squared plus B squared. Do I use 6 and 2 or 36 and 4? Does it matter which one comes first if I'm adding? No. C squared equals 36 plus 4. Add them together. Take the square root of both sides. C equals square root of 40, which equals what? 2 root 10? Yep, because that's 4 and 10, and the square root of 4 is 2. Yep. I'm going to cover all this. Root 40, what two integers would you say that's in between? Okay, I heard one person whisper it. 6 and 7. Why? Because 40 is between 36 and 49, and those two are perfect squares, yes? All right, so somewhere between 6 and 7. In which direction would I move? Up and down or right and left? Up and down. From the vertices or from the center? Center. 1, 2, 3, 4, 5, 6. So it's not as big as 7, so it's somewhere in between. 1, 2, 3, 4, 5, 6, right in between somewhere. All right, am I going to be extra critical on where you draw your foci? No. Now, if you drew them inside here in this rectangular shape, would I mark that wrong? Yes. If you drew them over here going right and left on this particular picture, would I mark that wrong? Yes. They should be going in the same direction as your vertices, in the same direction as your U shapes. And what determines which direction everything is going? What comes first? What comes first determines if everything's up and down or if everything's right and left. All right, what do I put here? 3 plus or minus what? 2 root 10. All right, transverse. Ask me a question. No? Question? No?
How'd you get the focus points?
This right here?
The points. The focal.
The -1, comma 3, all this right here?
No,
The numbers, the numbers here?
like where you plotted it.
How did I plot these here?
Yeah.
Okay, thank you. I had asked, I covered this and this, and I asked you what's the square root of 40? And you guys said it was in between 6 and 7, right? Because root 36 is 6 and root 49 is 7, and 40 lies between 36 and 49. So I just went up 1, 2, 3, 4, 5, 6, and right before I hit 7, somewhere in between 6 and 7, I put a star. And then I went down 1, 2, 3, 4, 5, 6, and before I hit 7, in between 6 and 7, I put a star.
So that's what's ever between is close to the 40.
Yes. Yep. Yep. Now be careful though, guys, because another big mistake kids make is they go their up and down movement from the vertices. Am I moving from the vertices? No, it's from the center. It makes sense you think it's from the vertices because when it's a parabola, we do move from the vertex. But this is not a parabola, it's a hyperbola, so we move from the center. If it has a center, everything moves from the center. All right, transverse and conjugate, the length of each one. Look back in your notes on the page before. Yes. The page before, which one's transverse? The distance between the vertices. So these two are my vertices, yes or no?
Yeah.
What's the distance from the 2 points, from one to the other? If I went up and down 2. 4. Conjugate is the length between the 2 points that are not. These 2 points here are the points that are not the vertices. I went right and left 6, so what's that total length? 12. Now, yes.
We put like x equals y equals.
For the transverse and conjugate? No, because it's just length. If it was an equation, you would have to put an x or y, but because it's length, 4 and 12 is good.
The total length from
Yeah.
one point to the other.
Yep, it's the distance, the length between one point to the other. Got it? Make sense? Can I say the transverse is always going to be the smaller length? No. Is it safe to say the conjugate's always going to be the larger distance? No. Is it safe to say the transverse is always the distance between the vertices? Yes. Whether that's big or small depends on the problem. All right, what's the last thing we have to find?
Ms. Torres?
Yes.
The vertices can be switched though, right? Since if you're graphing it the opposite way, then those would be the vertices.
If this exact same problem was flipped around and the x came first,
Yeah.
I would have the same rectangular shape, the same asymptotes, but my problems would be opening this way, or my U-shapes.
So then those would be the vertices.
And these here would be the vertices, in which case these numbers would have flipped, the 12 and the 4. Yeah? All right, equation of the asymptotes. Which formula did I say we were going to use? Point slope. What 2 things do I need? I need a point and the slope. The point's easy. Which point did we say we were going to use? The center. Okay, so I'm going to do y minus, if I'm using the center, y minus what? 3 equals, I'm going to leave the slope blank, and then x minus what? -1, so that's x plus 1. Okay, so put a note here somewhere that you're using the point is your center. The point is your center, and the slope we're going to find right now. What is slope a measure of? Rise over run. The change in y over the change in x. All right, I'm going to use this one right here. Do you agree? I know that it goes to the center and to the corner. That's what I told you guys to do. Yes or no? Yeah. So right now on your paper, I want you to count the rise and then count the run. Go ahead and do that now. Before reducing, what did you guys get? 2 over 6. Now what about going up and to the left to this corner right here? What are you going to get? Is it going to be -2/6? +2, -6? So could I put here plus or minus 2/6? Which reduces to plus or minus 1/3. Before you reduce, should you recognize that your rise is the 2 and your run is the A. Should you notice that? We'll see more of that in the next problem, but just at least make note of it. All right, so what do I put here? Plus or minus 1/3. Now, technically I have two different asymptotes. I have one positive slope, I have one negative slope. Does this equation here encompass both of those lines? Does it take care of both of them? Why? Plus or minus. Questions? All right. Number 2. X minus 1 quantity squared over 1/4, take away, and then y plus 5 quantity squared over 1/9 equals 1. What was that? Oh, I know. And I made a mess. Oh. All right, equals 1. And I did not say 1/2 there, did I? That should be a 1/9. I don't know what's going on today. So if you were listening, you would have put the 1/9. If you were watching, then you would have put the 1/2. Please fix it. All right, x minus 1 squared over 1/4 minus y plus 5. Okay. We're good? Center. HK, always x comma y, so what comes first here, the negative 5 or the positive 1? 1 comma negative 5. What is A, what is B? X, 1/2. And B is with the y, what is B? Where am I getting the 1/2 and the 1/3 from? The what? The square root? Yes? All right, square root of 1/9 and square root of 1/4. Okay. I don't know what is up with this eraser. Okay, because of the fractions, I'm going to make things pretty spaced out. All right, 1 negative 5. Okay, these numbers are really small, which means our shape is going to be really small, but we can still find all our bits and pieces. So, from the center, how far up and down am I moving? Up and down is the y, so up and down how far? 1/3. Now again, you the best you can approximate, because it's not like it has decimal values on here. And then how far right and left on the x-axis? 1/2. And then make your rectangular shape. And that is not part of our graph, but it helps us graph the what? The asymptotes. And the asymptotes help us determine how wide or narrow. Okay, before I graph, I need to know which direction it's opening. What helps us determine which direction it's opening? What was that?
So it's gonna be graphing left and right.
Okay, why is it opening left and right?
Because
Because the x comes first, yes or no? Okay, so these 2 points here are going to open up like this towards the asymptotes. Okay, right now then you can find your vertices. Go ahead and do that now. Okay. What are your vertices? Anybody have it? 2/3? 1.5? 1.5 comma -5? And then 1/2? Okay, because it's the right and left movement, right? And how far right and left did I move from the center? 1/2. And that's from the center being 1, -5. The one right 1/2 and left 1/2 gives me the 1.5 and the 1/2. Yes or no? Yes? Okay, foci, what is staying the same in from the center? The -5, yes or no? So if I'm moving up and down, what's going to change? The x, so it's 1 plus or minus the focal length, comma, -5. Go ahead and find the focal length now. (1/4 plus 1/9), is that what we have? C². Common denominator. 9/36 plus 4/36. Do you guys agree? Square root of 13/36. So root 13/6. Now I'm definitely not going to try to approximate that, but what do we know for sure? It's inside the rectangular shape or inside the cups? All right. Transverse, conjugate, and the equation of the asymptotes. Transverse, really quick, is what? The length between here. You went right and left 1/2 or 1/3? How far right and left did you go? Okay, so what's the total length here? 1. We went up and down 1/3. 1/3 plus 1/3 is 2/3. All right, I'm going to write at least the basis of my equation. Y minus y, which is -5. So what is it going to be? Y plus 5 equals blank for now. And then x minus what? 1. And what goes here? The rise over run. What's the rise? 1/3. What's the run? 1/2. Is it always these numbers here? Yes. How do you deal with a fraction over a fraction? You multiply by the, so 1/3 times 2/1 is 2/3. What do I need to put in front of the 2/3? Plus or minus. Whew. Make sense? This is the last new shape that we're learning. Everything else here after is going to be somewhat review.